Hello. Here you can see how changing the threshold on trackbars we are detecting edges of coins. Today I will show you how using OpenCV we can create and use these trackbars for edge detection. In this part, we will go through basic steps for image modification to get the exterior edges of the coins. I already created a coin counting folder in my working directory. Inside I have a Python file named coins and another folder named input where I have 3 images of coins. Check the video description for these files. You can also find the full code and useful links for more info. Okay, let's move to the code. We will be using 2 libraries, OpenCV and NumPy, so make sure to install them before starting to code. We will start by importing the OpenCV library. Import CV2. Next, let's open our first image. For that, let's create an image variable and assign it to cv2.imread. In brackets write image destination and image name with extension. Also, let's create a copy of our image and assign it to the image original variable. Imread function just reads the image, we need another function to open it. Let's write cv2.imshow and in brackets, we write window name and image input. We also need to add one more line, cv2 wait key and in brackets 0 to keep the image window open. Now we can run the code and see the image. We can see an image of coins. Let's close it and start modifying the image. There are many methods to get edges from the image. We will use probably the most popular edge detection method, Canny edge detection. The algorithm itself follows a 3-stage process. First, we convert the image to gray color space. Second, we reduce noise using blurring, and third, we apply the Canny edge detection function. Okay, let's implement it in the code. Let's convert our image to gray color space, cv2.cvtcolor, and in brackets, we add the image and cv2.color bgr2 gray. It will convert the current image color space to gray space. Next, we blur the image using GaussianBlur. Let's see OpenCV documentation. You can see that this function blurs an image using a Gaussian filter. We will need to define these parameters: input image, Gaussian kernel size, and Gaussian kernel standard deviation in the x direction. Let's create a blurred variable and assign it to cv2.GaussianBlur. In brackets let's add a gray image, kernel size 11 by 11 and 0 for sigmax. Next, we use the Canny edge detection function. In OpenCV documentation, you can see that this function finds edges in an image using the Canny algorithm. We will need to define these parameters: input image, first and second threshold for the hysteresis procedure, and output edge map. Let's create the edge variable and assign it to cv2.canny. In brackets let's add blurred image, threshold 1 to 30 and threshold 2 to 150, and the number of edges, 3. That's it for edge detection. But we will add couple more lines to find and draw contours. Contours will help us to eliminate interior edges. First, we will use Dilate function. In OpenCV documentation, you can see that this function dilates an image by using a specific structuring element. It thickens the edges, making some edges connect. We will need to define these parameters: input image, structuring element used for dilation or kernel, and the number of times dilation is applied. Let's create a dilated variable and assign it to cv2.dilate. In brackets let's add an edged image, kernel size 1 by 1, and make iterations equal to 2. Okay, and what's left is to detect contours. We will use the findContours function. It finds contours in a binary image. We will need to define the image source. Contour retrieval mode. Let's check available modes. We will use the first one. It retrieves only the extreme outer contours. This is exactly what we need. We also will need to define the contour approximation method. Here we also will use the first one, which stores all the contour points. We need all contour points because we want to detect the circle edge of the coin. Let's write contours, hierarchy equal to cv2.findContours, and in brackets, we add dilated image copy, contour retrieval mode, and contour approximation method. For now, let's leave our contours and let's see how our modified image looked in the image modification process and how many coins we detected. As we showed the input image, let's show all other images: gray, blurred, edged, and dilated. Also, we can very simply calculate how many contours or coins we have detected. We just need to print the length of the contours list. Let's run the code. A bunch of images has opened. Here is the input image. And we can see that we detected 10 coins. The same number is in the image. Let's add some order to the images to see the process. First should the input image, second, gray image, third, blurred image, in fourth we can see our edges, and in the last one they are thickened. In the next part let's group these windows and display our detected contours. To group or stack the images they must have the same shape. We will check images shape, and if it doesn't have the same shape we will modify them. For modification, we will use the NumPy library. Let's import NumPy as NP for short. Next, after our contours, we can add lines to check image shape. We write print and brackets image name and dot shape. We copy this line 4 times and change image names to gray, blurred, edged, and dilated. Before printing the shapes we can delete these imshow windows and comment the print statement. Okay, now let's run the code. We can see that the input image, before modifications, has 3 color channels and all others has just 1. This is what we expected, so if we want to stack all images together we need to modify the ones with 1 channel, or we can exclude input image and stack just modified images. That way we don't need to do anything. But there's a problem that we can face later. For example, if we will stack another image that has colors, so 3 channels, we will have an error. The same goes if we'll need to display any colored object, like a text. And it will be good to have a modified image name and color text. So let's modify the images to have 3 channels. We write gray equal to np.stack and in brackets, we multiply our 1 channel image by 3 and define the axis to -1. The axis parameter specifies the index of the new axis and the dimensions of the result. If the axis is equal to -1 it will be the last dimension. As a result, we will have the same image in 3 channels. The same we do for other images. If we check image shapes now, we can see that all are the same. So we are ready for stacking. We don't need these print statements anymore. Let's create an image list with all images we want to stack. Image is equal to list. And in it we add all modified images, gray, blurred, edged, and dilated. And after that, we can stack them. Let's create a new variable image stack and make it equal to np.hstack and in brackets, we add an images list. It will stack images horizontally. Let's add another line for vertical stacking. It's almost identical, we just use vstack. We will use a vertical stack when we will have bigger width than the height input image. For now, let's comment this line. What's left is to show this stacked image. We already know how to do it. We use imshow function. And the last thing for this part is to draw our contours. For that, we will use the draw contours function. In OpenCV documentation, you can see that this function draws contours outlines or filled contours. We will need to define these parameters, destination image, all the input contours, so what we found with find contours function, the parameter indicating a contour to draw, we will draw all, so it will be negative, the color of the contours and thickness of lines the contours are drawn with. Let's write cv2.drawContours and in brackets let's add image. Contours we want to draw, -1, to draw all contours, contour color, green and contour thickness, 2. And finally, we show this image naming the window as output. Let's uncomment the print statement and run the code. Okay, we have 1 window with all images in image processing and 1 window for output image where we can see the detected contours. And you can easily move these 2 windows as normal windows. What's missing is image names in the image processing window. To add image names we will create new variable window names and make it equal to all image names in a list. Next, we need to define a font we will be using to display our text. We will use Hershey's Simplex. Next, let's move these comments up because we will need some space to add our text. We will loop through our window names using enumerate and add the text to the top left corner. For index, name and enumerate in brackets we add window names. And we write image equal to cv2.PutText. Let's check this function in OpenCV documentation. So, it draws a text string. We will need to define the image, text string to be drawn, the coordinates where we want our text to appear, font type. Let's check all available fonts. We already defined the first one. Font scale, text color, the thickness of the lines to draw a text and line type. We will use the anti-alias line. So let's add an image stack. For text we will use fstring where we'll number our windows using an index. We will add 1 because it starts from 0 and we to start from 1 and window name. Next, we need to define x and y coordinates. Here we also will use an index. Because it will let us offset our text for each stacked window. We offset by 5 pixels and use image shape square brackets 1 to get image width. For y coordinate, we offset by 30 pixels from the top. Next, we add a font scale, 1, Pink color and BGR format thickness of the lines to draw a text, 2 in line type line AA. Let's run the code and see how it looks. We have numbered window names in the top left corners as we wanted. But the same code we can't use for vertical stacking. We need to change the X and Y coordinates. Let's comment code for horizontal stacking and uncomment for vertical stacking. For loop will be the same. And in the PutText function, we write 5 for X coordinate and 30 plus m.shape square bracket 0 times index for Y coordinate. And rest we leave the same. Let's try with the second image, coins 2. Texts were placed as we wanted. But we can see that our detected edges are not as we would like to be. We can change threshold 1 and threshold 2 parameters for the Canny function, but for another image, it could be that we will need new parameters and so on. So we will be changing parameters and running code until we found the right ones. It's time consuming and not very convenient. There is another method where we could use Trackbar and see live results with different parameters. Let's create a Trackbar. We will create 2 Trackbars for Canny function parameters threshold 1 and threshold 2. First, we will create a Trackbar window. Next, we will add 2 Trackbars representing threshold 1 and threshold 2. After that, we will give positions of these 2 Trackbars and use them for Canny function. Trackbar should work at current time, so we need to put all our code in a while loop. Let's write while true and tab all the code to be inside this loop. What else we need to change is to change the wait key parameter from 0 milliseconds of waiting time to bigger, for example, 300 milliseconds. So every 300 milliseconds our image processing window and output window will be refreshed. Let's run and see if the code works for now. Everything is good. Let's create a Trackbar window. Before while loop, let's add cv2.named window and in brackets Trackbar. It will create an empty window where we will put our 2 Trackbars. Let's see the documentation for the Trackbar. So create Trackbar function create a Trackbar and attaches it to the specific window. We need to add the Trackbar name, the name of the window that will be used as a parent of the created Trackbar, an optional pointer to an integer variable whose value reflects the position of the slider. Upon creation, the slider position is defined by this variable, the maximal position of the slider. The minimal position is always 0. And a pointer to the function to be called every time the slider changes position. Okay, let's create Trackbars. cv.create Trackbar in brackets we add Trackbar name, threshold 1, Trackbar window name, Trackbar, value, which reflects the position of the slider. Let's add 0 and maximal position of the slider. Let's add 255. And the function to be called every time the slider changes position. Let's add nothing. We write the same line for the second threshold, just now with the name of threshold 2. Let's move up and create an empty function nothing with parameter x. So it will do nothing, just pass. We can run and see what our window with thresholds Trackbars looks like. We can move it and the slides are working. Next, we need to get Trackbars positions. We move back to the while loop. Let's see the documentation. Get Trackbar pos returns the Trackbar position. We need to define the name of the Trackbar and the name of the window that is the parent of the Trackbar. Let's go back to the code and do that. Let's create the thresh1 variable and make it equal to cv2.getTrackbarPos and in brackets, we add Trackbar name, threshold 1 and Trackbar window name Trackbar. The same we do for the second thresh2 variable. Now we can add these variables to the Canny function and run the code. Let's try changing the thresholds until we have just the contours of the coins. Look like this image is tougher than we had before. Let's try with another image, but before let's change the GaussianBlur kernel from size from 11 by 11 to 15 by 15. And run with the third image. Okay, let's change image stacking from vertical to horizontal. For this image, it was very easy. You can try these threshold values for other images, but results may vary because most of the conditions of taking the image photo with coins should be similar to get similar results. Trackbars helps a lot, it is very simple to implement and you can see the results instantly. Hope you like this video. If you have any questions, leave them in the comments section. You will find the code in the video description. If you like this video, please leave a like and hit the subscribe button for more Python videos.